In today's lesson, we will learn about compound interest. We'll start with a little exercise to illustrate the difference between simple interest and compound interest. In simple interest, with an initial deposit of $100, earning 6% interest, after 1 year, we would have $106 because 6% of 100 is $6, and that would get added to our balance. Compound interest works the same way in the first year. $100 earning 6% interest would earn us $6. So after year 1, we would have $106 in both accounts. For simple interest at year 2, they go back to the original $100, you earn 6% interest, and you add that $6 to the 106, giving us $112. However, in compound interest, after the first year, we have $106 in the account, and we compute 6% of the $106. So on our calculator, we would take $106 times 6%. This time, we would earn $6.36 in interest, giving us a total of $112.36. At year 3, with simple interest, again they go back to the original $100, compute 6% of that, which would be $6, and add it to our $112. So you notice every year we're gaining $6. For compound interest, at year 2, we would earn 6% of the $112.36. $112.36. So we would take $112.36 times 6%. This time we earned $6.74. Adding that to my $112.36, I get $119.10. At year 4, again, we would go back to our original $100 in simple interest, compute 6% of it, which is $6. We'd add that $6 to the total, giving us $124. In compound interest, however, we would take the $119.10 we have, and we would earn 6% interest on that, which is $7.14. 15 cents actually with rounding. And then that $7.15 would get added to the $119.10, giving us $126.25. So you can see with simple interest, we're always earning interest off the original deposit. In compound interest, we are always earning interest on the initial deposit plus any interest we have earned. So you can see compound interest grows faster than simple interest, because in compound interest, your interest earns interest as well, where in simple interest, only your initial deposit earns interest. So if you were saving money at a bank, you'd obviously want compound interest because you'd receive more money at the end. So here are our compound interest notes. Compound interest is what banks and credit card companies use to calculate interest today instead of simple interest. The main difference between simple and compound interest is that in simple interest, only the initial deposit earns interest, or any amount you add later. So if you were to make an additional deposit later of, let's say, another $100, that $100 could earn interest. But none of the interest that you've earned will ever earn interest. In compound interest, your interest gets added to your balance, and the next time you earn interest on the entire amount, not just the initial deposit. The advantage of compound interest is that it builds your money faster. You're earning interest on your interest. The disadvantage of compound interest is that if you are paying back money with interest to a bank or a credit card, what you owe is growing faster than simple interest. The equation for compound interest is a little more complicated than simple interest. It is A equals P times 1 plus R over N to the N times T power. And we have to follow order of operations. So we would do what's in the parentheses first. We would divide these two values, add it to 1, then take that value to the power N times T, and then take that value times P at the very end. Now, all these letters mean something. A stands for the future value of the account. So the A is going to stand for the amount of money you have at the end of the interest period. P stands for the principal, that is your deposit. R stands for your interest rate, and that's right here. And remember, if it's 6%, you're actually going to put 0.06 into the equation. So we always turn it into a decimal. N is the number of compoundings per year, and that can vary. Sometimes they do interest what they call annually, which is 1 time per year. Semi-annually, which is twice a year, or 2 times per year. Quarterly means they divide the year into quarters, and you earn interest 4 times per year. Monthly, they divide the year into months, and you earn interest every month, so it'd be 12 times per year. Or daily, which would be 365 days per year in the equation. All of those numbers are what we would use for N, okay? So these values would go in here in the equation. The T stands for the number of years that you'll be earning interest. As part of your assignment, you'll notice that I have a page that you will have attached to your assignment that has this information on it, so that you can refer to this whenever you need to. I'm not expecting you to memorize this formula, or really any of these values. You can always use the sheet to refer to get your answers. So let's do a couple examples. Example 1. Your 3-year investment of $20,000 received 5% interest, compounded semi-annually. What is the total return on this investment? So I'm going to use my equation. A equals P times 1 plus R over N to the N times T. Now I'm simply going to plug in my values. The principal is $20,000. That's the P. The 1 in the equation is always there, no matter what the problem. The interest rate, R, is 5%, so I turn that into 5%. N stands for the number of compoundings a year. The problem said semi-annually, so that means that N is 2, because it's going to happen twice a year. And then I'm going to use that 2 again up in the power, because there's another N right there, so N is 2. And then the T stands for years, and it's at a 3-year investment, so that's the 3. So the first thing I would do is the inside of the parentheses. So inside the parentheses, I would divide first 0.05 divided by 2. I don't know if you can see that or not. 0.05 divided by 2. Add 1 to that, and I get 1.025. So this is 1.025. And then 2 to the 3rd power, or I'm sorry, 2 times 3 is 6. Now I'd have to do the exponent next. So I would do 1.025 to the 6th power. And that's a pretty long decimal. You can just leave that in your calculator. And then just hit multiply by 20,000. So the total amount of my investment after 3 years would be $23,193.87. We always round these to the nearest cent, since it's money. So the key is, fill in the equation with all the values, do the parentheses first, and in the parentheses we have to divide first, then add the 1. And while you're doing that, you could also multiply the 2 times 3. And then we're going to do 1.025 to the 6th power and multiply that answer by 20,000. Let's try another example. So it says you borrow $59,000 for 2 years at 16.5% interest, which was compounded annually. What total will you pay back? So this is like you have a credit card. Credit cards typically charge very high interest rates. So I would take my equation and fill in the values. The principal is how much money you borrow or deposit into the bank or credit card. The 1 is always part of the equation. The interest rate was 16.5%, which translated to a decimal is 0.165. This is compounded annually, which means once a year. So that'll be a 1. And that'll be a 1 because there's 2 n's in the equation. And it was for 2 years, so that's a 2. So again, I would do this first. So 0.165 divided by 1, which is just 0.165. Add it to the 1. It would be 1.165. 1 times 2 is 2, so that's the power. And now I would take 1.165 to the 2nd times 59,000. And I get $80,076.28. So you can see, with that high interest rate, like a credit card would give you, even though your original purchase was $59,000, you're going to end up paying back almost $80,000, or a little over $80,000. That's why credit cards are, you got to be really careful with them. They're not a good deal. Let's try one more example. It says your allowance of $190 got 11% interest, compounded monthly for 1.5 years. What is it worth at the end of the 1.5 years? So I have my equation. The principal is the $190 allowance. The 1 is always part of the equation. The interest rate was 11%, which I convert to 0.11. It said compounded monthly. That means 12 times a year. So n is 12. I use the 12 again because there's 2 n's. And it was 1.5 years, so I make that 1.5. So first step is to do what's in parentheses. So 0.11 divided by 12. Add it to 1. I get this, 1.00916666. 12 times 1.5. I would do that at the same time here. I get 18. And now I would take this value to the 18th power and then multiply by 190. So 1.0091666 to the 18th power times $190. And at the end of the 1.5 years, I would have $223.92. So again, fill in the values into the equation. Do what's in parentheses first, and inside the parentheses, you need to do the division first. So divide, add the 1. At the same time, you can multiply these two together, giving us 18. Then, by order of operations, the next step is to take this to the 18th power, because exponents comes next. And at the very end, we multiply by 190. Remember, the key difference between compound interest and simple interest is that in simple interest, only your initial deposit earns interest. In compound interest, your interest earned earns interest as well. So the money grows a little faster.